is using our exponential modelling. And for the first one, so the model represents the number of birds that are migrating each season, and then the number of days since they've migrated. So the first one is to find the population of the birds at the start of the migration season. So if T is the number of days since the start of the migration season, then if we want to know them at the start, it's when T is equal to 0. So you're just finding when T is 0. So I can do this two ways. I can either substitute in, which would be P is equal to 1350 plus 400 times 1.25 to the power of 0. And I can substitute that into my calculator and find that I get 1,750, or what I think might be the better way here, because we're obviously going to be using this a few times, is to write down the equation in your calculator. So all I'm doing here is typing in this equation. So it's 1.25 to the power of x. Because I can't write the t, I need to write the x. And we probably need to sort out the window here. So maybe we go from -2. The only reason we're putting a minus there is so that we've got something. And it's in days, so let's maybe go up to 365, and then we've got the full year. And since we've already got a starting population of 1,750, maybe we need to go to about 2,000, just so that we can see what's happening on our graph. Okay, let's change this. Okay, so we can start to see what's happening. Obviously, we need to extend our y value much larger. Maybe we try 3,000. And we can start to see the graph. So for the first one, it was when x was equal to 0. And we can see there straight away 1750. And then for the second part, it was to find the population at 5 days. So I'm going to do exactly the same again. This time I want to know when x is 5. And I can see there it's 1,000, if I got my equation correct. It should be a negative x. So this is the power of negative x, so we should always check. There we go. So this time, at 5 days, we can see it's 1,481.072. So if I'm writing that to 3 significant figures, it would be 148 and then 0. You would also get the mark there if you left it in the full format. You can also show for the examiner, just in case it's wrong, that you know it's when t equals 5, and then that would be enough working for you if you had got that wrong as well. For the next question, we are calculating the time taken for the population to decrease lower than 1,400. So we now need to know, when does it cross the line of 1,400? So on this one, the p-value is 1,400, and we want to know what is t. So if I go to my graph here, I can see it crosses somewhere around here. I'm actually just going to extend my window a little bit further, just to make sure that I've definitely got that intersection. I can see it somewhere here, and trace, intersect, and somewhere around here. There we go, and we can see that it happens at around 9.32 days. So it's when the t value is 9.32 to 3 significant figures. And then the last part here is, according to the model, find the smallest population that is possible for the birds. So essentially it's asking for the asymptote, and we know that the asymptote is always the kind of d value or the c value at the end of our exponential, and that means that it is just 1,350, and you can give a reason there that it's the asymptote if you needed to as well.